Okay, so in example 1, you're buying a new computer and it originally cost $2,100. That's its original value. It says that the computer depreciates, and that word depreciate just means that it is going to go down. So I'm just going to write out to the side, it's going to go down in value by a value of 50% each year. And this problem is wanting us to write an exponential decay model describing the situation. So we need to know some key pieces of information. Firstly, we need to know our initial value. So our computer originally cost $2,100. This piece of information, super important. It represents our A value. We also need to know how much its rate is decreasing by. And our rate is decreasing by 50%. That represents our R value. And remember, when we think about rate, we want to change that to always be a decimal. So right now it's given to us as a percentage, but we need to change that to be a decimal, and 50% as a decimal is just equal to 0.5. Okay. Now that we have our A value and our R value, we can do a little bit of plugging in. So our original value was $2,100. So where we see this A down here for our exponential decay formula, we're going to plug in 2,100. Now, our rate that we decreased by was 0.5. That was our R value. So we're going to plug that in where we see R. And remember, this is a function as time is passing, so we don't really have to change anything else about the t or the f of t. Those get to be just pulled straight up. And we also get to leave that 1 minus r alone. So our equation is almost finished. We get to just simplify it a little bit more by subtracting this 1 and 0.5. And when we do that, we find that f of t is equal to 2,100 times 0.5 to the t. And this is an exponential decay model that's going to represent this situation up above.